Alrighty. Hey everybody, my name is Frank. This is the PothOnProgramming video log, and today we're doing part 12 of the Stay Down devlog, and that's going to be adding graphics to the game. So we got a couple things to do. We got to make a loader so we can load the graphics in, and we have to make a renderer so we can actually render the graphics and keep all that rendering code in its own place. This way it's not polluting the rest of your game state code, or my game state code, I guess. So two things to do. Let's go ahead and get started. So the first one I'm going to do is the loader, so we could load this in. Oh, I should also mention, I already added the images in, because I figured you don't really need to see me do that. So we got, oh, they're kind of tiny. Got like a main character image. I think I'm going to have selectable characters. So we're going to have like a main character image. The platform images I'm keeping pretty much the same at this point. And then the diamond. So let's go ahead and make a loader. I'm just going to say new file, loader.js. I'm going to copy this, do that, and remove all of this code. Probably could have just typed this out, would have been easier. Set loader, we're going to set it to a function that returns an object. Okay, so there's our loader object, and then inside of the main staydown.js file, we're going to go ahead and define loader, and we're going to define a get and a set method for loader. So let's go in here, get loader, return loader. This way we can actually use get loader to pull it into our run game state. And then we are also going to need a setter, so set loader, cool. Alright, and then we also need to pull that file in here, so we're actually loading it. Now when I was testing this, because I pre-build these examples a little bit to figure out, what I need to do for the actual videos. So I have like another file with all my files in it. I have another folder with all my files in it, and I mess around with that. And when I get something I like, then I come over here and make a video. So when I was testing this, it didn't work in Edge for some reason. And the thing that didn't work was it just didn't want to load this file. I literally had this file empty, and Edge just wasn't even loading it. I just literally had like alert hello inside the file, and Edge just didn't want to load it for whatever reason. If you encounter any issues trying to replicate what I'm doing now in Edge, upgrade to the latest version of Edge, because that's what I did and it fixed the problem. So not really a good explanation of why whatever was happening, but it did fix the problem. So now that we have our loader, we need to give it a public method to load some images. So I'm just going to say load images. It's going to take a list of URLs, or an array of URLs. And I could do this with promises, and I messed around with that a little bit, but I think I'm actually just going to use callbacks. So this is going to take a list of URLs and then a callback function. And the callback function is just what's going to be done when the images are done loading. So right now, what I can do is I can come in here and I can say, inside of my initialize function, I could say loader.load images, pass in some URLs. It's going to be, let's see, media / images / what do we got in here? We got diamond, making Dominique a playable character, and then also platform.png, copy the path. Could put this, like this first part of the path that's the same in the actual loader, because in this project all my images are going to be in this folder. For now I'm just going to leave them here. I might refactor that later if I think that's a good way to do it. And then we're going to come down here and we're going to say function, it's going to get images back. And then all of this stuff that we do to actually start the game, like start the engine up and everything, we're going to put that inside the callback. This way, when our images are done loading, this callback function gets called and we actually start the game. And this way we ensure that the game, when it starts and the run game state actually starts, it's going to have access to all these loaded images instead of starting the run game state before we finish loading the images, and then you're going to run into problems where you don't have images to draw. So that would definitely be a problem. So let's go ahead and see if this works. It doesn't work. Let's see why it doesn't work. Huh, that's weird. Oh, you want to know why it doesn't work? Because loader doesn't actually do the callback. If I come in here and say callback, now it's going to work. Okay, but we don't want to do the callback right away. We actually want to load our images first. So what I'm going to do, I'm not going to use promises or anything fancy. I'm just going to make an array of images, and this is going to be what we return. So this is going to hold all the images. I'm going to make a counter. Counter equals urls.length. And then you'll see what the counter is for. We're going to do a for loop for, let's see, index equals urls.length -1. Index is greater than -1. We're going to loop backwards. Index minus minus. So now what we need to do is, for each URL, we need to make a new image. So I'm going to say image equals images index. We're going to store it inside of images index as well, equals new image. So for each one of these URLs, we're creating an image. Then we need to try to load the image. So image.source equals urls at index. We also need to add event listeners for load and error, just in case something happens when we're trying to load our image. We want to catch the error as well. This way we can do something about it. So let's do image.add event listener. We're going to add a load event listener. It's going to take a function. I'm going to call it resolve. And you could actually come in here and just define this resolve function and use this option for event listeners. Set once to true. I just want to cover this. I'm not going to use this, but you could use this. If you add this option to your event listener, after the event listener, I guess, catches an event and your handler fires, it removes the event listener automatically. So you don't have to call remove event listener if you put once equal to true inside of your event listener properties when you add it. So I'm not going to do this, but you could. I'm going to do it the old-fashioned way. So we're going to add one for load and error, one for error. I'm going to use the same function, and then up here above the for loop, I'm going to define the resolve function. And it's going to take an event property, and let's just see what we get. Image event.target on these is going to be the image that we added the event listener to. So let's just do image dot. Let's get the image dot width when we load these things up. So let's see. This should work. This should work. Let's see what happens. We're not going to call the callback, so we're not actually going to get any of this on the screen. We get 16. I think all of the widths of these are going to be 16. So whatever the image this is, 16 width, 16 width. Okay, so they're all 16 width, but all three loaded and all three had the right width. So that's actually good. So now let's do alert event.type. because this is where we're going to determine whether or not we have an error or whether it actually loads successfully. So load is the event type when the image loads successfully, so all three of these are going to be load. But let's go in and just mess up one of these, and I'll do, instead of diamond, I'll do diadmond, I guess, and we'll refresh. We've got one loaded image, probably for platform. An error, I guess it's just loading them in any old order. The error is going to be for this URL, which is obviously incorrect. There's no file at that destination, so we catch that error, or we have the capability of catching that error. So I'm not actually going to do anything yet when there is an error, but I just wanted to make you guys aware of how you should handle, or how you should determine whether or not there was an error loading. You can just add the error event listener, and then you can use event.type to determine if there was an error when it was loaded. Or you could even have two separate event handler functions, and you could pass those in as well, but I'm just going to do one. Alright, so now that we have our image, we're going to do image.remove, remove event listener, load, resolve. We have to remove the event listener from it. If I was to use once, like I talked about earlier, we wouldn't have to do that. Remove event listener, error. There we go. And finally, what's going to make this work is the counter. So we just have to say counter minus minus. And every time an image loads, the counter knows when we set it up that there are 3 images in this URL's array. Because over here we defined an array, we pass it into load images. It has 1, 2, 3 URLs in it. So counter is going to be equal to 3. Every time an image loads or has an error loading, counter is going to decrement 1. And we're just going to check to see if counter equals 0. Use strict quality there. You don't have to. You could use double equals. I'm just going to use strict. If counter equals 0, then call the callback. And I'll even do an alert so we can see this in action. Alert counter, save, this should work. Alright, so we start out with 2 because we decrease the value of counter by 1 before the alert. So it started out as 3, now it's 2 after the first image loads, now it's 1 after the second image loads, now it's 0 after the third image loads, and now when it's 0, we know all 3 have loaded, or however many we pass in have loaded, and we can call the callback. And then everything inside the callback, inside of stay down, goes ahead and runs. So this is a great way to load multiple images, keep track of how many there are, and then do something when all of them are done loading or have encountered an error, and then you can put your own error handling into the loader. So that's a good way of doing that. Some people might be like, why don't you just use promises? Well, the reason I decided not to use promises is because I looked at some benchmarks, and granted they were from 2018, so they're 2 years old, but callbacks were a lot faster. And I think the reason callbacks are a lot faster is just because it's just a function. You're passing the function in, and you're calling it at a certain time. Your event handlers are going to have to do their thing, and the event listeners are going to have to do their thing. That's pretty much a standard either way, but for some reason in 2018 promises were a little slower, and I figure when I could write something this simple and get the same effect, why would I use something slightly more complex that might be slower? So you can go ahead and use promises if you like. I'm going to stick with this for now unless I run into some kind of problem with it, but it worked fine when I was testing this. So alright, so now we actually have to do something with our images because we have them loaded up. We know they're loaded properly because it returned the right width for each image, even though it was all 16. So now we just have to make our renderer and then use the renderer to draw those images into the game. So let's go ahead and make a new file, call it renderer.js. I'm just gonna write it. We're gonna do stay down.set renderer function Okay, and then inside of this self-calling function, we're going to return object literal, and that object literal is going to hold all of our public methods for this renderer. So now let's go back to the main file, come up here, make a local variable for renderer, add some getters and setters. Return renderer. I don't think I need these spaces because that's easy enough to read anyway. And then we have to set the renderer because we just called that function that we haven't defined yet in the renderer file itself. Okay, so we have everything we need. We need to pull the file into the main HTML. So we're going to say script source equals renderer.js, save, refresh. Nothing is broken yet. Let's go ahead and do some rendering stuff with this. Okay, so well, before we even do that, we have to do something with our images, because right now we are in the main.js file. We are loading our images. We have this callback here that does something with them, but we don't actually store them anywhere. So I think what I'm going to do for the time being is just have like a global object that holds all my images, and then I can reference that global object inside of my different game states. The problem that I'm thinking I might run into with that is I might only use certain objects or certain images in certain game states. Like the player image, the diamond image, that's probably only going to be really used inside of the run game state. Maybe inside of the pause game state, but probably not, because I could just save the static image from the last frame of the run game state and use that as the background of the pause game state. But then there's other things like text. I'm going to have an image for all the text in the game, basically just a text character sprite sheet, and that's going to be used in almost every game state. So that's an image that I would want to keep in a global variable that everything has access to. And then I have these other images that I might just want to use in one game state. So I might have to come up with a different solution for this, but for now I'm just going to store all my objects in the main file here. So I'm going to have an object called images, and then when I load them in, let's see what we got. Diamond, and got these images that we're going to load, going to save, and then we're going to come in here and we're going to say pull in images. Oh, wait a minute. Gonna have to differentiate there a little bit. Images 1. Two. There might be a more elegant way to do this, but for now I'm just going to do it this way, and we'll see what we get. Let's see if it works, and then we can get back to the renderer. Okay, so that works. Now in my run game state, I should be able to pull in one of these graphics. So let's do renderer equals staydown.get get the renderer. We're also going to be pulling images in. I think that should work. Let's see what we get. Works. Alright, so now we have pulled the renderer into the run game state. So down here inside of my render function, I should be able to say, call a function from the renderer to draw one of the images. So let's go to the renderer. draw an image. It's going to take the image, and we're also going to have the x, y value. This is going to have to pull in display, so we're going to do display equals stay down dot get display, and then we're going to come in here and we're going to say display dot draw image. I'm going to take the image, okay. So basically we're just drawing this image at the specified XY coordinates. That's really simple to have inside of our renderer. And we're just passing in the image, passing in the XY, cool. And we come back to the run game state, and close this and this because I don't need those open. Come back inside the run game state, down here, inside of the render function, I'm just gonna try to render renderer dot draw image. I'm going to pass in images dot diamond. I'm going to try to draw the diamond at 100 100. See if it works. Doesn't work. Let's see what happened. Can I read property width of undefined at object.drawImage? Okay, so up at the top, let's see what we're getting. We're trying to pull in images. Let's alert images and see what we get. It's an object. Images.diamond, let's see what we get. Undefined. Why is it undefined? Let's go to stay down and see. Oh, my bad, because I'm referencing images instead of images underscore. Because the callback function that I'm passing to the load images function has this parameter called images underscore. So when I'm setting my actual local images for the stay down object, I'm going to reference that with images. And then when I'm referencing the ones returned from the loader, I'm going to use images underscore. So this should fix the problem. Let's see if it does. Still undefined. Can I read property 0 of undefined? Function images. Let's look at our loader and see if I failed to return anything. Oh, I totally did. Let's do return images. Fresh, still undefined. Why is it undefined when it's still drawing it? As you can see, it's actually drawing the diamond, so we know it works. That's pretty cool. Let's go to wherever that alert was and see why it's not working properly. I think it's inside a run. Why is that not working when I call images.diamond? Undefined. I'm not going to dwell on that too much because it is working. I might figure that one out later. Let's see if we can switch this up a little bit and get the other ones to draw just to see if they're working. We'll do, where am I drawing this? At the bottom. Save. Alright, cool. By the way, very small. We're going to fix that in a minute. Basically, we're going to draw a pretty small game world, and we're going to just scale it up with the CSS scaler. I don't know what episode we did that in. Maybe the last one or 2 episodes ago. And then what was the last one? Platform. Yeah, pretty tiny platform there. Okay, so we're going to use this to replace our current renders that we're doing. So we're using the Canvas API to draw everything. Instead of that, we're going to use our render object to take care of all this for us and pull all of this drawing specific code out of our actual run game state. This way we can worry about drawing inside the renderer object, which I feel like is where it belongs. We can worry about game logic for the run game state inside the run game state and not have to think about too much of these drawing commands. So let's take a look what we got here. we're first going to draw the platforms. So instead of fill rect, I'm going to do renderer.drawImage images.platform, and then platform.x, platform.y. Easy. Then we're going to do items. For now, the only item is the diamond. We're going to have to revise this later. Instead of doing this, all this draw code, I'm just going to say renderer.drawImage images.platform. Oh, nope. Images.diamond, and then item.x, item.y. And then for the player, we're going to get rid of this, and we're just going to say renderer.drawImage images.Dominique. All right, save, refresh. All right, so we have everything. For some reason, gravity stopped working. So let's back up a little bit and see what happened here. Oh, my bad. I put 100, 100 in for the location. So it's always going to do 100, 100. What I need to do is player.x and player.y. Save, see what we get. Why is it a platform? Okay. All right, so it works. The hitboxes for these things are still the same. We haven't changed that. We've just changed the graphics. Obviously, everything's really small, which is kind of a pain to look at. So what I'm going to do now is I'm going to resize the world, and we're going to do nice easy 256 for now. Save, see what we get. All right, so it scaled it up a bit. It's a little blurry, but we're going to fix that. These platforms obviously are too sparse. Let's go down here where we set everything up. We're going to have to go into the platform manager method or object here for a second and set how big our platforms are going to be. They're 16 wide. I'm going to find a better way to associate the width of the platforms with the width of the platform image that it's using. But for now, we're just going to do 16:4. That's the hard-coded size of the actual platform image. So let's refresh that. Now we can see the player hitbox is wrong, but we fall off the right side of the platform because the platform hitbox is right. So now let's go to the player and fix that hitbox. Player, where are you? Inside of constructors. So let's go to player, and we're just calling a rectangle. When we set up the player, now it's going to be 16 wide and 32 high still. All right, cool. Refresh. It's a pain to test with, but as you can see now, the hitbox is much more reasonable. Eventually, for problems like this, what you're seeing here where we're not even standing on it, eventually when I start doing animation, we're going to actually have our individual images that we're going to draw for each object is going to have a frame object associated with it, and it's going to have an offset. This way we can have whatever size hitbox we want, and then the hitbox for the object is decoupled from the actual rectangle for the image we're drawing. And that's really what we want. But for now, we just have a really rudimentary way of doing it. We're just hard coding in the size of the image. This way we get something that looks okay when we're actually running this example. So for now, we're hard coding that, but later on when we get into animation, we're going to actually have the right size hitbox and the right offset for the image to go with that hitbox, so everything works the way you would expect it. All right, so next, first let's see if we can actually, man, moving way too fast. So I scaled everything way down in terms of world size, and now the movement is just like over the top, and we're drifting a lot. So we're gonna fix that, but first let's fix the number of platforms on the screen that are popping up here. We're gonna go into the run game state. We're gonna come to the bottom. We're gonna say world width minus 16, because that's the new width for platforms. And this is also gonna change, by the way. We're not gonna be doing this at the bottom here. Let's do, instead of minus 16, let's do 18. Let's see what we get. All right, cool. So that looks a lot better, I think. Got a lot more going on in terms of platforms, because we did make them smaller width-wise. Before, I think they were 48, and now they're 16 width. The only thing now is it's kind of hard to control the player because she is just drifting all over the place like crazy. And before, that drift was not too much of a problem because the player was actually twice as wide. But now it's definitely an obvious problem when you're trying to control. So let's go ahead and go into the run game state. We're already there. Come up to the top where we have some constants. Change the constant for friction. I think I'm going to go with 0.75 and see what that gets us. Oof, I do not like that. Look at the fall. The fall is so, it's like stiff, like it's a really old school game with that gravity. Also the jump. I can't even get to the bottom. It's kind of the point. It's gonna be hard to stay down literally in the game, so that's maybe a good thing that I can't get to the bottom, but it's hard to test the jump this way. Okay, let's try 0.8 instead. Alright, that's a little bit better. We're falling at a more reasonable speed. I like that quite a bit better, and I feel like I have more control over... I can't jump as high though. I feel like I have a little more control over the player in terms of like what platforms I'm landing on. So that's definitely a plus for movement. Alright, enough fiddling with that. We can always fine tune it later. And then... what else do we need to do? We need to fix the blurriness, because if we take a look at this in full screen, get rid of this thing, you can tell it's definitely super blurry. So what we need to do to fix this is actually going to be some CSS, because we're not using drawImage to scale up. We're actually using the CSS. If you remember back to either the last video or a couple videos ago, we're using CSS to scale the actual graphics here. So let's go into the HTML, come up to our CSS style definition. We're gonna come in and we're gonna select canvas, and we're gonna try a couple different things out because I got a couple different results in testing. One was for pixelated, so image rendering, pixelated. So let's try pixelated and see what we get. We're gonna go from this to this. So that is definitely pixelated. Get this. You can see like when we stop moving, there's gonna be motion blur. Oh, that's another thing we have to do, because we're drawing on fraction X and Y positions. We're drawing on not whole numbers, and when you don't draw on whole numbers, your anti-aliasing is going to try to position your pixels halfway between the actual screen pixels, and that's going to cause some blur. That's why you can see there's a little bit of blur when we move side to side. Man, these platforms are kind of annoying to deal with. Let me fix this real quick. We'll go to the run game state, we'll come down to the bottom, and we will give ourselves a little space just to observe the graphics in. So we're gonna say if it's less than, not 1000, but 100, then we can stop. All right, so now we have a nice little space over here where we can actually take a look at the graphics. So can you catch that little blur there when we stop moving? The reason for that is as our speed is being degraded by friction, we're being drawn on half pixels, and it's gonna kind of blur us up like that. which I want to get rid of. So let's go into the renderer, which is where we can do this, and we're just going to use Math.floor to convert these XY coordinates from potential decimal values to whole numbers. And the reason I use Math.floor instead of Math.round is because we want to be consistent. We always want to be going to one side or the other side. We don't, let's say we have 1.5, we don't want to round up and then when we have 1.4 round down. We want to be consistent. If we're anywhere within the range of 5, so 5.1 to 5.99, we want to round down to 5. This way we're only offsetting in one direction. It's going to keep the game looking more consistent. I don't know if I'll be able to show you that, but just take my word for it. You can write out some numbers and round back and forth between them and then use Math.floor, and you'll see that you're more consistent with Math.floor. You're not going to be like getting a jitter when you're moving. So let's go ahead and refresh. We're trying to fix the problem of that little blur. So let's refresh. All right, so now we have gotten rid of the blur. Instead of the blur, what you're going to get is a slight jitter. As you can see, when we slow down, we're kind of getting a little, almost like a jitter, and that's because the Math.floor is just snapping us to the closest, or the closest whole number that is, let's say we have 5.9, it's going to snap us to 5. So when we go from 6 to 5.9, it's going to snap us to 5, and you're going to notice that. And then we're going to stay at 5 until we get to 4.9. So when you're using like friction or something like that to degrade your motion slowly, and you start moving in small increments, like small decimal increments, like 0.1, you're going to get that snapping. But I think that looks a lot better than the blur. You might not think so. If that's the case, feel free to, use whatever you want. You don't have to use Math.round. You can draw on the decimals if you want and get that little bit of blurriness. That might be preferable to you. So let's see how this works in other browsers, because when we're messing with the CSS, that's definitely going to be a pain point when you're working with other browsers, because they all interpret it differently. So I'm going to copy this path. I'm going to open up Firefox. You know what? I was testing this on a Windows computer where I have Edge installed. I do not have Edge installed because this is Linux. I don't even know if I can get Edge installed, so we're going to test on Firefox. I tested this in Edge and it works okay if you use crisp edges, I believe. Let's go to the file path that's the right file path. Alright, so here we have the same thing running in Firefox. And as you can see, we have some blur, some pretty serious blur, and that's because Firefox does not like image rendering pixelated yet. It might like it someday, but for right now it doesn't care for it much. So we're going to do image rendering crisp edges. There might be some kind of like Moz prefix as well. So when we use crisp edges with Firefox, we're going to get what we expect. We're going to get those nice crisp edges. We're going to have the same jitter because that's just JavaScript math in the background, but we're going to get nice crisp edges like we expect. Let's see how that affected Chrome. Didn't affect Chrome. So we can have pixelated and crisp edges. I'm not sure if the CSS setting canvas rendering style to crisp edges is going to overwrite the first definition for pixelated. Let's see what happens when we remove that. So we're going to come in here, we're going to get rid of pixelated, save, refresh. Yeah, so with Chrome, we're still setting it to crisp edges, but Chrome doesn't like that. Chrome would rather have pixelated. Firefox, I don't know where my Firefox window went. Firefox obviously would rather have crisp edges. So just be aware, the different browsers you're using, they're going to be finicky with any CSS you use. They're also finicky with their implementation of drawImage too, so you might have some issues with that as well. But the solution is apparently to just come in and do both. So let's go ahead and do that. Now in Chrome, we've got a nice good look, and in Firefox, we also have a nice good look. I wish I had Edge so we can test in Edge as well. But when I was testing this, when I was fiddling around with this example in like another folder that's just made for testing before I actually go do the real video and write the real code that's going to be in the project, I was testing with Edge and everything worked fine when I had pixelated and crisp edges. So if you have any questions about that or have any problems with it, just leave a comment or something, or hit me up on Discord. The link to join Discord is on the website. So there's a link to the website, and then at the top of the website there's a link to Discord, so go ahead and click that. I think this is actually going to do it for this video. So before we go, let's go ahead and go back to the run game state and bring our platforms back. And if there's any fine tuning to be done, I'm going to make this 2. Wait a minute, this should be 16. If it's less than, if it's less than 15, we don't want to draw another platform. Sorry, I'm losing my train of thought here. That's not right either. If X, oh, because X is the left side of the platform, my bad. So we're gonna just do 0. Save, and then we're gonna get platforms all the way across with a little margin there, but we'll figure all this out in another video. Anyway, that's a really rudimentary way to load multiple images. A really simple way to use a renderer to go ahead and draw your images. Obviously, this is going to be populated with some more useful functions besides just drawImage. And having that is a great way to go ahead and clean up your renderer function inside of your main game state. Because now instead of all that drawing logic, we just have a reference to a function in the renderer, which is where you would expect your rendering code to be. So thanks for watching, guys. I'm gonna go ahead and get out of here. Hope you guys enjoyed the video. Feel free to, oh, didn't mean to close that one. Feel free to hit me up in the comments or on Discord, and I'll talk to you later.